Hello everybody, welcome to EDUSURE's 50 days and 50 topic sessions of UGC NET. We will be covering 50 topics in 50 days to help you ace the UGC NET JRF exam. Today is Mathematics Day and I will be picking up the topic Matrices and Determinants from your course. So let's start. So what is a matrix? A matrix is an arrangement of elements into rows and columns. Okay. So first of all, what is a matrix? A matrix is an arrangement of elements. Now, generally in mathematics, the elements will be numbers or you can have variables also. So arrangement of elements into rows and columns. This is to make our life easy. Okay. So for example, if I have a matrix 1, 2, 3, 4, 5, 6. So how many rows are there? 1, 2. How many columns are there? 1, 2, 3. So there are 2 rows and 3 columns. So this is called a 2 by 3 matrix. How do you read it? 2 by 3 matrix. So if a matrix has m rows and n columns, so you will read it as m by n and write it as m cross n. So it is an m cross n matrix. Now this m cross n is called the order or dimension of the matrix. So what is the order of the given matrix A? The order of the given matrix A is 2 by 3. What is the dimension of the given matrix A? The dimension of the given matrix A is 2 by 3. How many elements are there? 6. So you have to multiply the number of rows by the number of columns. That is 6. So what is the number of elements? Number of elements is equal to mn. Okay. This is the basic structure of a matrix. Okay. Now, we also denote a matrix as Aij. Okay. Now, what is Aij? Aij is nothing but the element in the ith row. The element in the ith row and the jth column. All right. So, for example, if you have a matrix A, so this is A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay. And this is a 3 by 3 matrix. So first row, first column, first row, second column, first row, third column. So positioning is done like this, Aij. All right. Now, how do you add two matrices? How do you subtract two matrices? So operations on matrices. Operations on matrices. The first operation is addition. The second operation is subtraction. The third operation is multiplication by a constant. Now, when can you add two matrices? You can add two matrices only when they have the same order. You can subtract two matrices only when they have the same order. That means if I tell you to add 1, 2, 3, 4 with the matrix 1, 2, this is impossible because the order of this matrix is 2 by 2 and this order is 1 by 2. Okay, so to add and even to subtract, you should have the same order. So how do you add? So you will be adding, suppose you have a matrix of the form Aij and you have another matrix of the form Bij. So the new matrix will be of the form Aij plus Bij. In subtraction, it will be Aij minus Bij and multiplication by a constant K. So Kaij is the matrix K times Ij. What does it mean? It means that I am adding the elements position wise. That means if we have 1, 2, 3, 4 plus 0, 1, 5, 6, you will be adding 1 with 0, this 2 with this 1, this 3 with this 5, and this 4 with this 6. So the addition is done position wise. Similarly, subtraction is done position wise. And suppose you want to multiply with minus 3, 1, 2, 3, 4. You have to multiply each and every element. Minus 3, minus 6, minus 9, minus 13. So these are three operations: addition, subtraction for same order matrices, multiplication by a constant. You take the constant inside, multiply it with each entry. Okay. The most, typical, or you can say difficult operation in matrices for students is matrix multiplication. So how do we multiply matrices? How do we multiply matrices? Okay. So when we multiply two matrices, so this is matrix A, which has order m into n, and this is matrix B, which has order p into q. So A into B is possible. A into B is possible if and only if and only if n is equal to b. Mind it that I am saying A into B. That means the matrix A will be positioned first and the matrix B will be positioned later. Because matrix multiplication is not commutative, AB might not be equal to BA. All right. So what does it mean? It means the number of columns of the first matrix is equal to the number of rows of the second matrix. And how do you multiply? Let's take an example. So suppose you have a matrix A, which is a 2 by 3 matrix, then of course B has to be 3 by something matrix. So let B be a 3 by 1 matrix. Okay. So the resulting matrix AB will be of what order? Now, the order of the remaining matrix is M into Q. M by Q. So similarly, the order of the matrix AB will be 2 by 1. Okay. So let us create a matrix, 2 rows and 3 columns, 1, 2, 3, minus 1, 0, 5, and 3. This is 3 rows and 1 column. So 1, 2, 5. Okay. And now I want how many rows? I want 2 rows and 1 column. So basically you will be having an entry like this. All right. So how do we multiply two matrices? You take the first row and then you multiply with this column and you will get this entry. How do you multiply? First entry with first. So 1 into 1 plus 2 into 2 plus 3 into 5. And then to get this entry, you pick up this row, again the same column. So minus 1 into 1 plus 0 into 2 plus 5 into 5. So this is 1 plus 4 plus 15, then minus 1 plus 0 plus 25. And now you can calculate it. This is going to be 20 and this is going to be 24. This is how we do matrix multiplication. So the operations on matrices are clear. All right. So now some terminologies. What is a square matrix? What is a square matrix? A square matrix is the one where the number of rows is equal to number of columns. That is what a square matrix is. What is an identity matrix? An identity matrix is a square matrix. First of all, in the identity matrix, the number of rows and the number of columns have to be equal, and all the diagonal entries are 1, others 0. Example, identity matrix of order 2. I will not write 2 by 2, 2 rows and 2 columns. So that is going to be 1, 0, 0, 1. Identity matrix of order 3, 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, and so on. So this is a square matrix. This is an identity matrix. Now, transpose of a matrix. Transpose of a matrix. What do you mean by transpose of a matrix? Transpose of a matrix A is equal to A dash or A T or A small t. These are three notation. So what is transpose of a matrix? Transpose of a matrix is the matrix obtained by reversing or interchanging the rows and columns of the parent matrix. For example, A is the matrix 1, 2, 3, 4. Then A transpose will be the matrix 1, 2, 3, 4. That is called transpose of the matrix. Now we will have certain rules for transpose of the matrix. And what are those rules? So if you do the transpose twice, you'll get the matrix back. The transpose of the sum is equal to the sum of the transpose. The transpose of the difference is equal to the difference of the transpose. If you multiply a scalar with a matrix and takes the transpose, then the scalar comes out and multiply with the transpose of the matrix. Now, AB transpose, this is very different. This is equal to B transpose, A transpose. The order reverses. Please remember this. Please do not write AB transpose is equal to B transpose, A transpose. That is A transpose, B transpose. That is not true. This is true. So these are properties of transpose of a matrix. Now, there are certain terminologies related to transpose of a matrix. What are those terminologies? Symmetric matrix and skew symmetric matrix. So what is a symmetric matrix? A symmetric matrix is the one where A is equal to A transpose, and a skew symmetric matrix is the one where A transpose is equal to minus A. These definitions are very important. Sometimes they are directly asked. They will ask you to check whether the matrix is symmetric or skew symmetric. So please remember the definitions. Please remember the terminologies also. Okay. So these are the terminologies related to transpose of a matrix. Now we will come to determinant. So what is a determinant? What is a determinant? A determinant is a number. It is a number associated with. It is a number associated with a matrix. In fact, a square matrix, we will always calculate determinant of a square matrix. So how do you calculate determinant of a matrix like this? A, B, C, D. This will be AD minus BC. Okay. So for example, you have to calculate determinant of 1, 2, 3, 4. Now the terminology of determinant is, we have this absolute value sign. So 1 into 4 minus 2 into 3. So this is the notation for determinant. You also write determinant of A, or you write this, or you write a triangle. So these are the notations. All right. So we know how to calculate determinant of a 2 by 2 matrix. Now, before introducing the concept of determinant of a 3 by 3 matrix, I will tell you what are cofactors and minors. Okay. So first we will talk about minor. So Mij is called minor of Aij. Okay. It is the determinant. It is the determinant left after removing ith row and jth column. I'll explain it to you through an example. And what is capital Aij? It is cofactor of Aij. It is minus 1 I plus j Mij. Okay, so let us start. Suppose A is a matrix 2, 5, 6, 0, 1, 2, 1, 1, 8. Suppose somebody tells you what is M12. Now, what is M12? M12 is minor of A12. What is A12? A12 is entry in the first row and the second column, that is 5. So I want to know the minor of 5. So we have to remove the ith row and jth column. That means we have to remove the first row and the second column. So we have to actually hide this element like this. So what is the determinant left? 0, 2, 1, 8. So this is 0 into 8, 0, minus 1 into 2, 2. So minus 2. That is the definition of minor. And what if somebody asks you A13? A12. A12 is minus 1 power 1 plus 2. M12. So this is minus 1 power 3. M12 is minus 2, which is minus 1 into minus 2, which is 2. So this is called cofactor of A12, the element A12. All right. So now, how do we calculate determinant? How do we calculate determinant of a 3 by 3 matrix? Okay. So how do we calculate determinant of a 3 by 3 matrix? All right. So choose a row oblique column of your choice. Okay. Then multiply each element in the row. Multiply each element in the row oblique column with its cofactor and add. Now, what does it mean? Suppose you have this determinant 1, 2, 3, 0, 1, 5, 6, 8, 2. Okay, you want to calculate this. Now, choose a row of your choice or a column of your choice. So, suppose I choose the first row. So, I have chosen the first row. Okay, so I will take one, multiply it with its cofactor. So, cofactor of what is the position? A11 plus 2 cofactor of A12 plus 3 into cofactor of A13. That is what I have told you in this. Multiply each element in the row oblique column with its cofactor and add. So, now what is cofactor of A11? Minus 1 power 1 plus 1 minus 1 1. 2 into minus 1 power 1 plus 2 M12 plus 3 into minus 1 power 1 plus 3 M13. So this is 1 into 1 M11. This is 2 into minus 1 minus 2 M12. This is 3 minus 1 power 4 is 1 M13. So what is M11? Hide the first row and the first column. So 1, 5, 8, 2 minus 2. M12, first row, second column, 0, 5, 6, 2. Okay. And then plus 3, first row and the third column, 0, 1, 6, 8. So this is 2 minus 40, minus 2, 0 minus 30, plus 3, 0 minus 6, and find the answer. So minus 38 plus 60 minus 18. So minus 38 minus 18 is minus 56 plus 60, which is going to be 4. So, you choose a row or a column of your choice and you will always get the same answer. So that is how you calculate determinant of a 3 by 3 matrix. All right. Now we have another concept, singular matrices and non-singular matrices. So what is a singular matrix? What is a singular matrix? A matrix is called singular whose determinant is equal to 0. What is a non-singular matrix? A matrix is called non-singular matrix if its determinant is not equal to 0. This is also very, very important because they will use the word singular in any question and then they will expect you to solve a question. So you should know what is a singular matrix in the first place. All right. Now, another concept, adjoint of a matrix. Adjoint of a matrix. Okay, I will take example of a 2 by 2 matrix. You can do it for 3 by 3 also. Adjoint is always defined for a square matrix. So what you have to do, if you have a matrix A is equal to A11, A12, A21, A22. मैंने positions लिख दिए हैं. So what you have to do, you have to first find the cofactor matrix. What do you mean by cofactor matrix? You will be replacing each entry by the cofactor. That means A11, A12, A21, A22. And then what is adjoint of A? Adjoint of A is cofactor matrix. Cofactor matrix transpose. That means it will be A11, A12, A21, A22. This is called adjoint of a matrix. Now, so for example, if you have A is equal to, let's take a very simple example, minus 1, 0, 5, 2. So first of all, we will find the cofactor matrix. So A11 is cofactor of this. Hide this. So minus 1 power 1 plus 1. Hide this. What is the determinant left? 2. So determinant of a single element is the single element itself. Okay. Then this is going to be 2. Now, what is A12? Hide this element. So minus 1 power 1 plus 2. Hide 0. You will get 5. So this is going to be minus 5. A to 1, hide 5. So with a 1 minus 1, power 2 plus 1, hide 5, you'll get 0. So this is 0. A to 2. So A to 2 will be hide 2. So minus 1 power 2 plus 2 into this minus 1 after hiding. So minus 1. So what is cofactor matrix? Cofactor matrix is A11, A12, A21, A22. So what is adjoint of A? Adjoint of A is 2 minus 5, 0 minus 1. That is how you find out adjoint of a matrix. Now there are certain results about adjoint of a matrix and determinants of a matrix. Let me tell you those. So determinant of A into B is equal to determinant of A into determinant of B. Determinant of K times A is K power N, determinant A, where K is a real number and A is an N by N matrix. This is very, very important. Okay. Now, determinant of adjoint of A is equal to determinant of A ki power N minus 1. All right. Determinant of A transpose is equal to determinant of A. There are certain mistakes that should be avoided, which are mistakes to avoid are you cannot have determinant of A plus B equal to determinant of A plus determinant of B. Determinant of A minus B is not equal to determinant A minus determinant of B. These are blunders. Please don't commit them. This is not true. Only this, and this is true. Clear? Then we have one very beautiful theorem, which is always true. So adjoint of A when you multiply with A is equal to A when you multiply with adjoint of A is equal to determinant of A into identity matrix. This is always going to be true. So how are you going to use it? For example, if you are given A is equal to 1, 2, 3, 4, and somebody asks you, calculate adjoint of A into A. Now, if you want to avoid calculating adjoint of A and then multiplying with A, what you have a very smart move. This is nothing but determinant A. So 1 into 4 minus 2 into 3 minus 2 into I. So what is I? 1, 0, 0, 1. So this is nothing but minus 2, 0, 0, minus 2. Understood? So sometimes these kind of formulas really help you to solve a problem when they deliberately give you the problem to identify whether you know the formula or not. So rather than calculating the adjoint A, then multiplying with A, and then answering, you will use this. Now, you might say, why I want to do this and I'll do it. I don't want to learn this. But this is very handy if you have a 3 by 3 matrix, because calculating the adjoint of a 3 by 3 matrix is possible, but it is a very tedious task and it will consume a lot of time time is very, very important. It is money if you're giving an entrance examination. So therefore, to save your time, please remember these kind of formulas. Now, the next concept is inverse of a matrix. So what is inverse of a matrix? Inverse of a matrix. So B is called inverse of a matrix. B is called inverse of a matrix if and only if, okay, inverse of a matrix A if and only if AB equals to BA equals to I. This is the definition of inverse of a matrix. Now, for example, AB is equal to I, and we denote B is equal to A inverse. All right. So we want, this to be equal to I. So now, when is A inverse possible? So what is the definition of A inverse? definition of A inverse is 1 upon determinant of A adjoint of A. That is why calculation of adjoint of A was very important. This is how you calculate determinant of a matrix. So you can see that inverse of a matrix. You can see that A inverse exists if and only if determinant of A is not equal to 0, because division by 0 is not allowed. So A inverse तभी exist करता है जब determinant A non-zero होता है. That means we have a non-singular matrix. Okay. And A inverse doesn't exist if determinant of A is equal to 0. That is a singular matrix. So you can also be asked to calculate determinant of a given matrix. So just divide the adjoint by the determinant. For example, we have already calculated adjoint here. Okay. So if you want to find out A inverse is 1 upon determinant A. So what is determinant? Minus 1 into 2 minus 0 into 5, which is minus 2. So 1 upon minus 2 and multiply by adjoint. This is your inverse. You can further simplify it. Minus 1 divide by minus 2, all the terms. Okay, this is the inverse of the matrix. So this is how you calculate inverse of the matrix. Now some properties about inverse of a matrix. So AB inverse is equal to B inverse A inverse. It is reversed like in the case of transpose. AB transpose is B transpose A transpose. All right. Then A transpose inverse is equal to A inverse transpose. This is also very, very important. Okay, you take transpose first, then inverse, or you take inverse first, then transpose. Both mean the same thing. All right. Then you have determinant of A inverse is 1 upon determinant of A. This is also very important. Now, blunders to avoid. A plus B inverse is equal to A inverse plus B inverse. ऐसा कुछ नहीं होता है, आप ऐसा नहीं करेंगे. A minus B inverse is, A inverse minus B inverse and so on. So this is about inverse of a matrix and determinant of a matrix. All right. Thank you very much. Please subscribe to our channel to see such 50 useful videos, very, very useful, up to the mark videos to clear your UGC NET exam. And all the very best. Keep on coming and keep on getting wonderful content for your UGC NET journey. Thank you very much.